Shalom. Welcome to the Einstein exhibition here at the Bloomfield Science Museum, focusing on the life and work of Albert Einstein. My name is I'm a graduate student in astrophysics here at the Hebrew University and also a guide at the Science Museum. I'd like to invite you to join me on a short tour of the exhibition. This exhibition was organized by the Museum of Natural History in New York, the Hebrew University of Jerusalem, the Bloomfield Science Museum in Jerusalem, through the support of the Jerusalem Foundation and the Israeli Ministry of Science and Technology. Come inside and let's take a look at the first exhibit, and perhaps together we'll be able to understand what makes Einstein, well, Einstein. This display case we see here contains 4 scientific articles written by Einstein, all published in 1905 in Germany, in what was then the world's most prominent physics journal. These 4 articles changed the face of the world. They are the reason 1905 became known as the miraculous year of Albert Einstein. In 1905, Einstein had not yet begun to save his handwritten manuscripts, but we do have these original printed copies of the articles. These articles became the cornerstone of modern physics. In the first, Einstein proposed a mathematical model in which described the random movement of tiny particles suspended in liquids, what's known as Brownian motion. In so doing, Einstein demonstrated the molecular structure of substances, a concept which at the time was still under a lot of contention. The second article dealt with the photoelectric effect. Einstein proposed that light consisted of a stream of tiny particles, basic units of energy called quanta. He explained the essence of electromagnetic radiation, the interaction of light and electrons contained in matter, and by using that also explained the photoelectric effect, the current of electricity formed when light strikes metal. The third paper, titled On the Electrodynamics of Moving Bodies, was Einstein's crowning achievement of that year. It was the first version of his theory of relativity, a theory that would completely change what anyone had ever thought about space and time. One of the fundamental concepts presented in this theory, described in the 4th article, is the connection between mass and energy, as expressed in the famous equation E equals mc squared. These articles not only vastly changed our understanding of the physical world, they were the springboard for monumental technological developments in the 20th century that have influenced and still influence each and every one of our lives. It should be remembered that in 1905, Einstein was only 26 years old, having just handed in his doctoral thesis. He was working full-time as a government clerk, as in patent office in Bern, Switzerland, to support himself and his family, and therefore had no real connection with the scientific community of the time. These articles were written entirely in his spare time. So it wasn't only the content of the articles, which was amazing, but the conditions under which Einstein wrote them, and the pace in which he wrote them, that make 1905 truly a miraculous year. Of course, such an outstanding body of work doesn't just appear out of nowhere. Einstein had been mulling over the concepts in these articles for a long time, some of them since he was 16. After 1905, it was just a matter of time till Einstein was awarded the most prestigious recognition given to scientists, the Nobel Prize. In this display case, you can see the certificate and medal from the Nobel Prize Foundation Albert Einstein received when he was granted the prize in 1921. At the time, Einstein was already world famous due to the 1919 solar eclipse observation, which validated his general theory of relativity, which had been published several years earlier. However, the certificate cites his contribution to the field of theoretical physics, and most notably to our understanding of the photoelectric effect. The reason for that is that at the time, a scientific and even a political controversy was still raging over the concepts of the theory of relativity. The members of the prize committee chose to avoid the issue by not mentioning the achievement in the certificate at all. Luckily for them, Albert Einstein had more than enough scientific contributions worthy of a Nobel Prize. In his acceptance speech in July 1923, Einstein spoke only about the theory of relativity, nothing of the other accomplishment noted in the certificate. He also affected Einstein's beliefs and his views. Einstein spent the First World War in Germany, where he held a position at the University of Berlin, one of the most prestigious institutions of the time. Einstein, though born in Germany, harbored a great dislike for German nationalism which was prevalent at that time, and also towards militarism in general, which dated back to his school days. He went so far as to renounce his German citizenship and change it for a Swiss one. Living through the First World War, Berlin further consolidated his pacifistic beliefs. And as always, he was not afraid to voice them. Throughout the war, he was active in intellectual circles in an attempt to further the peace. We find here an example of one of these activities, a correspondence he held with another well-known German intellectual, Sigmund Freud. Einstein was interested in the psychological aspects of violence and aggression which led to war, and turned to Freud to learn more about the subject. Correspondence, Freud described his beliefs on the matter, and both he and Einstein tried to voice opinions as to how this aggression could be stemmed and how peace can be brought about. Another turning point in history was the Second World War. We can learn something about the role he played in the Second World War by this correspondence we have here. A correspondence he held with a Japanese magazine editor, the magazine Kaizo. The editor, Katsuhara, wrote to Einstein in 1956. Einstein had already been to Japan in 1922 when he was already world famous. And everywhere in the country he went, he was accepted as a hero. In 1952, the US occupation of Japan ended. The world was seeing the first published photographs of the terrible destruction wreaked by the atomic bombs in Hiroshima and Nagasaki. The editor asked for Einstein's reaction to those photographs. In his letter, he asks, "What are your reactions when seeing the photographic reproductions showing the destructive effects of atomic bombs? What do you think of an atomic bomb as the means of slaughtering human beings?" The next Third World War is commonly called the Atomic War. Does this not mean the destruction of mankind? Why did you cooperate in the production of atomic bombs, knowing full well there's such a destructive power? Einstein replied at once, his response letter here, in which he corrects common misconception of his role in the forming of the atomic bomb. In his letter he writes, "My participation in the production of the atomic bomb consisted of a single act. I signed a letter to President Roosevelt. The letter addressed the necessity of a large-scale experimentation to ascertain the possibility of producing an atomic bomb." He cites his reasons for signing the letter. "I was well aware of the dreadful danger for all mankind if these experiments would succeed. But the probability that the Germans might work on that very problem with a good chance of success prompted me to take the step. I did not see any other way out, although I always was convinced pacifist. To kill in wartime, it seems to me, is in no ways better than common murder." After the Second World War, since 1945, he became a strong proponent of nuclear disarmament. He continued to do so until his death. In 1945, he said, "This weapon was delivered into the hands of the American, the British nations, in their roles as trustees of all mankind. But so far, we have no guarantee of peace, nor of any of the freedoms promised by the Atlantic Charter. The war is won, but the peace is not." Words that still ring true today. Throughout his life, Einstein saw himself as a citizen of the world, not identifying himself with any nationality. He was, however, of the freedoms promised by the Atlantic Charter. The war is won, but the peace is not. Words that still ring true today. Throughout his life, Einstein saw himself as a citizen of the world, not identifying himself with any nationality. He was, however, very much connected to his Jewish heritage. In 1919, Albert Einstein joined the Zionist movement, demonstrating his support for a Jewish homeland in the Middle East. He was called upon to help establish a Hebrew university in Jerusalem, to which he readily agreed. Working closely with Chaim Weizmann, then head of the World Zionist Organization, their dream was to create an institution that would attract the world's best young Jewish researchers and bring honor to the emerging state of Israel and the Jews the world over. In 1921, Einstein traveled to the United States with a group of fundraisers, headed by Weizmann. When he arrived in New York, Einstein told reporters, "I know of no event that has given me such as the proposal to establish a Hebrew university in Jerusalem. The traditional respect for knowledge that Jews have maintained intact through the many centuries of severe hardship has made it particularly painful for us to see so many talented sons of the Jewish people cut off from higher education in Central and Eastern Europe." When the university opened its doors in 1925, Einstein was on the board of trustees and headed the academic council. To mark the occasion, he wrote a special declaration called "The Mission of Our University," shown here. The mission of our university, which was read by Jews around the world, described the university as a place that expresses the universality of the human spirit. Einstein says he hopes that our university, as he called it, would develop quickly as an important cultural center valued by the entire civilized world. But perhaps the greatest expression of his long-standing commitment to the Hebrew University was his decision in 1950 to donate all of his papers to the Hebrew University, making the institution one of the world's greatest repositories of his intellectual legacy. All of those documents, and many others that have been added over the years, are housed in the Einstein archives at the university. The collection is an invaluable asset to the people the world over. It contains a wealth of handwritten manuscripts, correspondence, articles by and about Einstein, photographs, and caricatures. All of this material sheds light on Einstein's special character, his scientific and public activities, his Jewish identity, and his personal life. Many of the items on display in this exhibit are part of the archives. An example of this are some of the many letters Einstein received in his life from children. Children felt no qualms about contacting this famous scientist and writing him letters, asking him questions, even giving him advice. Through these letters, we see what Einstein symbolized to children the world over, and also from Einstein's responses, we can learn something about his special relationship he felt to these children. For example, one of the letters read, "Dear Dr. Einstein, my father and I are going to build a rocket and go to Mars or Venus. We hope you will go too. We want you to go because we need a good scientist and someone who can guide a rocket good. Do you care if Mary goes too? She is 2 years old. She is a very nice girl. Because everybody has to pay for his own food, because we will go broke if we pay. I hope that you have a nice trip if you go. Love, John." But first of all, foremost, Einstein was a scientist. Let's look over at some of his scientific contributions. One of the effects of Einstein's theory of special relativity is time dilation. A clock, which is moving relative to me, will tick slower than my clock, which is fixed in my system. The faster the relative motion, the slower the ticking. This applies to any clock, even our biological clocks, that determine how fast we age. The exhibit we have here demonstrates this idea. Let's look at the first clock in the series. This clock, on the far left, we see that the seconds tick at the same rate that the seconds on my clock or your clocks at home tick. We can follow the ticking by looking at the changing of light from panel to panel. However, what happens when we include motion? Let's imagine that each of these other clocks were placed in a spaceship. Spaceships all fly off the Earth at different speeds. The spaceships all left the Earth at the same time on the 14th of March, 1879, Einstein's birthday. At that point, the clocks were all synchronized showing the same time and the same date. As these clocks placed on the spaceships hurtle through space, notice that time is measured differently in each clock. First of all, we notice that the ticking is lengthened. If you look at this clock, going at 99% of the speed of light, we can see that it ticks once in about 8 seconds compared to our clock. We can look at the time and the date and notice that on this clock, the date is still January 26, 1897. If cloning were possible in the 19th century, and we could clone 5 little Alberts and place them on the spaceships, then the Albert Einstein traveling on this spaceship would only be 17 years old. If you look at the last clock, which is traveling at 99.9999% of the speed of time, the speed of light, sorry, we see that the date here is still March 14, 1879. Albert Einstein, or his clone, which is traveling on the spaceship, is still less than a day old. This shows us that in Einstein's theories, certain forms of time travel might be possible. If someone in space, the spaceship carrying little Albert, were to turn around, come back, he might come back to us still being a young boy. This, of course, is only possible in one direction. You can go forward in time this way, but never back. Another aspect of Einstein's theories was his general theory of relativity, which changed the way we look at time, space, and gravity. In it, Einstein proposed a completely new way of looking at the force of gravity. What he suggested was not a force acting between two bodies, but rather an interplay between mass and space. The mass of an object changes the curvature of space around it. It bends and distorts space. I have a friend here to help me show this on our exhibit. We'll ask Muella to stand in the middle of this, in front of the screen. On the screen, we can see in Shmuela and I, we have placed a very, very massive object, a black hole. We can see the black hole represented here as this dark area where light can't escape from. But we see that the effect of the black hole, the effect on the surrounding, is very pronounced. The light coming from Shmuela is bent and distorted, showing us a very, very different view from what we know what it looks like. This effect happens not only here on our screen as a nice little picture, but also can be observed in space. When astrophysicists and astronomers look through telescopes at the night sky, sometimes they see images of galaxies bent and distorted. The reason for that is that the light coming from the galaxies is diverted due to the curvature of space because of some massive objects, like a black hole or a very, very massive galaxy. These distortions of the light, which act like a lens, were called gravitational lenses by Einstein himself in the last paper that he published before his death. Using the distortion of light, one can learn a lot about the galaxies. Just like a magnifying glass, these gravitational lenses enhance the image of the galaxy in the far background, allowing us to see it more clearly, but also by looking at the distortion, we can learn quite a lot about the black hole itself, about the dark mass that actually changes the light around it. This is a very, very powerful tool for physicists and cosmologists doing their research. It shows us a way that we can actually see Albert Einstein's predictions and theories come to life. As we said before, Albert Einstein didn't deal only with theories of relativity. His contributions to science were many and diverse. And one of them, published in 1905 in the paper on Brownian Motion, was his validation of the molecular view of structure of substance. The idea of Brownian motion, the phenomenon itself, had been around for many years. It all began in the early 19th century when a botanist in England called Robert Brown observed pollen powder under a microscope. You can see his observation today. Okay, just a second. Well, now let's look together and see what Robert Brown saw himself through his microscope. Well, too bad. Not everything in physics can work all the time. What Robert Brown saw was little pollen powder, and we saw them moving around. This came as something of a surprise. Pollen itself is not a living material, so why is it moving around? When he looked at larger clumps of pollen, they were stationary. Nobody could really understand this little jiggling random motion because nobody really understood where the forces were coming from. Before Einstein came along, somebody had already suggested that maybe this was an effect of the molecules in the liquid bombarding the pollen grains around. However, if the bombardment is random from all different directions at the same time, it should add up to zero eventually. So where did this little jiggling coming from? Einstein explained correctly that even though the total amount of forces average out to zero, little fluctuations of the collisions can actually push the little pollen grains around. This causes a little jiggling motion from side to side. What he did in this paper was explain not only the phenomenon of Brownian motion, but he actually managed to validate through a mathematical model the existence of the molecules, thereby showing that the molecular structure of matter was actually true. At the time, nobody was really sure if this was the case or not, but since Einstein's time, we know that atoms and molecules are the building blocks of any substance we have around us. So this is the extent of our little tour. We hope you enjoyed it. If you have any questions, we'd be happy to answer them, either about the exhibit, about Albert Einstein, about his scientific contributions, or his life. We'd be happy to answer them. We'll wait for your questions.
We have one question, again from Italy. Has Einstein ever lived in Jerusalem?
Einstein never lived in Jerusalem. However, he did visit in 1921, I believe. He came for a short visit on his way to Japan, where he visited the Palestine as it was known at the time. He visited Jerusalem and held a speech at the site where now stands the Mount Scopus campus of the Hebrew University in Jerusalem. The speech was before the establishment of the university and was towards the establishment that would come in a few years.
Okay, that was very interesting. And if I can add something, at the Historical Museum in Bern, I learned that Einstein was offered the presidency of the State of Israel when the first president of Israel died.
Well, I have with me Professor Hanoch Gottroyd, who will answer this question since he's much more knowledgeable than me on this issue.
Okay, let's dwell a little bit on the... Please.
Indeed, he was offered the presidency of the State of Israel, and in a very short, handwritten reply to the Prime Minister of Israel, David Ben-Gurion, he regretfully rejected that offer, and the reason that he gave in that letter was that he knows a little about nature, nothing about human beings, and therefore it would not be appropriate for him to assume a position of leadership. But in the same letter, he also added that he is very sad for having to reject that offer because his relationship with the Jewish people has always been his strongest human bond, ever since he became aware of our precarious situations among the nations of the world.
Oh, he was very sensitive to your case, I know, and I've seen this letter in the Historical Museum in Bern. this letter where he declines the offer or presidency of the Israeli state. Are there any more questions?
In fact,
Yes, please go ahead.
may I add to that? Because 3 days later, he wrote a letter to the editor of one of the newspapers in Israel, and there he gave another reason for rejecting that offer, saying that he had to be concerned with the possibility that the Israeli parliament might adopt a law or a resolution which would be in conflict with his conscience, and as a president he would be helpless.
Okay. He was very modest, always a lot of sense of humor as well.
Well, the two colleagues that are sitting with me here are Professor Yemima Ben-Menachem from the Department of History and Philosophy of Science at the Hebrew University, and Professor Yaakov Beckenstein from the Institute of Physics at the Hebrew University. One of the questions that we received, and that actually most of our audiences ask, why is Einstein so famous? Why 50 years after his death, he is still so much alive? So if my colleagues here would agree to shed some light on this question, what they think. Yemima, you want to say something?
Well, I think it's always a combination, like with best-selling books, it's always a combination of the greatness of his work and other things that are a matter of personality and circumstances. But one thing that one can say is certainly that with Einstein, the notion that science may undergo revolution has become part of our thinking about science. I think with Einstein, we lost our naivete about science. We don't think of science anymore as the final truth about almost anything. We can still hope to reach the final truth, but we've also become skeptical.
Do you want to add something to this?
Well, I want to be more specific. I think that we think of Einstein as a great scientist, maybe the greatest, because he took in actually 3 great revolutions in physics. Usually 2 are mentioned, but there were 3. He invented basically special relativity, which we use as a framework for basically almost any physical theory. And he was one of the first that gave ideas to quantum theory, was the other great revolution of the 20th century, and finally invented the modern theory of gravitation, which substituted for Newton's gravity theory. And we are just, in the last 2 decades, realizing how central general relativity is to the understanding of the universe. So the man that had to do with other important contribution to all 3 great revolutions of physics of the 20th century certainly deserves to be considered a great scientist.
We have a question for
and
Israel.
If I may add to that something else, it's clear that his fame stems from his achievements in science. If not for that, we wouldn't care about what he said on many other issues. But having said that, I think that there is no other individual, scientist or non-scientist, whose name is connected with essentially the major issues that were on the agenda of mankind the first half of the 20th century. He expressed his views on all that. He, sometimes naively, always bluntly, listened to him, and he had an impact.
So we got this question from the Neuroscience News organization, and the question is, it is often reported that Einstein was religious, but in the Albert Einstein archive, he is quoted saying, "My position concerning God is that of an agnostic." Is this quote contained in the Hebrew University archive, and can you expand on some of his other quotes regarding religion?
Well, Einstein was not a religious man in the ordinary sense of the word. He did not identify with religious institutions or with religious ritual. Still, he did not want to be referred to as an atheist. He developed, just as he developed his own physics, he also developed his own religion, to which he referred as cosmic religion, and his concept of God was closest to that of another great Jewish philosopher, Baruch Spinoza, and there are numerous quotations in which Einstein describes his attitude to the concept of God as being revealed in the harmony of nature and not as an anthropomorphic entity that is concerned with what people do or do not do.
So basically a personal belief. Thank you very much, Israel. I have to close the connection with you.